Good morning, students. Let's start with today's session. Theorem 6.4. Theorem 6.4 states that if a transversal intersects two parallel lines, then each pair of interior angles on the same side of a transversal is supplementary. So let us see this theorem manually. So let's draw a line and we choose parallel line. So line G is parallel to line F having points A and B. Taking another point on line G, taking another line as a transversal which intersects these two parallel lines. Transversal EF intersects parallel lines at distinct point H and I. So let's measure the angles formed by this transversal. We'll measure co-interior angles, that is, angles on the same side of a transversal. So when I measured the angle AIH, it came out to be 125.92 degree. Similarly, I will measure angle IHC. The measure of the angle is 54.08 degree. When we add these two angles, sum is 180 degree. So this was the theorem which was proved manually. Moving on to the next theorem, that is 6.5, it states that if a transversal intersects two lines such that a pair of interior angles on the same side of a transversal is supplementary, then the two lines are parallel. Please complete it over here. It is then the two lines are parallel. Let's see this theorem manually. First, let's draw a line AB which is acting as a transversal later. Let's take 2 points on the line AB, that is C and D, and through C and D I will draw known angles, two angles whose sum will be equal to 180 degree. So I am taking the first angle to be 135 degree and drawing a ray CD. I am taking another angle to be of 45 degree, which is co-interior to the first one. So drawing another ray, that is DC dash. Now we can see that sum of 135 degree and 45 degree is 180 degree. So this will act as a co-interior angles, that is angles on the same side of a transversal. And we need to prove that if we draw a line through CD dash or C dash D or extend it through by making it two lines, then the two lines so obtained is parallel or not. We need to see this, that these two lines are parallel or not. For this, I will measure the distance between 2 points at different positions. So now we will measure the distance. It came out to be 2.17. Similarly, over here it is same 2.17, and so is 2.17. This shows that these two lines are parallel. At each point they are equidistant. So we proved this theorem manually. Moving on to the next topic, that is lines parallel to the same line. Theorem 6.16. Lines which are parallel to the same line are parallel to each other. So let's prove this theorem manually first. So first I will take a line AB. I will make a line which will be parallel to the first line, that is AB. I am taking another line which will be parallel to line AB. We need to show that line G and H are also parallel. So for this I will make a transversal. I will measure one of the angle. As these two lines are parallel, then their alternate angles must be equal. So let's see. And the transversal is intersecting at three distinct points. As these two lines are parallel, that means that their alternate interior angles must be equal. So let's check it. So the angle came out to be 68.11 degree. So we can see that alternate interior angles are equal as the line AB and CE are parallel. Since line A, B and DF are parallel, that means alternate interior angles must be equal, so the angles are equal. So we can see that angles are equal, but we can also see that these two corresponding angles are equal. So according to corresponding angles axiom, these two lines are parallel. And we can also check for the alternate interior angles, and it came out to be equal, so these two lines are also parallel. So this theorem was proved manually. You can also prove mathematically. This was theorem 6.6. Lines which are parallel to same line are parallel to each other. Moving next to exercise 6.2. In this we are taking question number 2. So The question number 2 is, in figure 6.29, if AB parallel to CD, CD parallel to EF, and Y is to Z is equal to 3 is to 7, we need to find X. So here we have to use theorems which we learnt earlier. So in this we have been given AB parallel to CD and CD is parallel to EF. So from this we say that, which we learned theorem 6.6, we can say AB parallel to EF. Lines which are parallel to the same line are parallel to each other, and we have also been given ratio between Y and Z, and we need to find X. So we can see here that line AB and EF are parallel from equation 1, which we just do it. So we can say that X will be equal to Z as they are alternate interior angles of a parallel line. So here, if the ratio, whenever there is a ratio, we can suppose that y will be equal to 3p suppose, and Z will be equal to 7p. So here X is equal to Z as these are alternate interior angles of the parallel line AB and EF. So X will be equal to 7p and Y will be equal to 3p. As we can see that AB is parallel to CD. So sum of X and Y will be equal to 180 degree, as these are the angles on the same side of a transversal. So they are supplementary. So when we add, it comes out to be 10p. So X plus Y is equal to 180 degree as they are supplementary angles, that is angles on the same side of a transversal. So 10p will be equal to 180 degree. So P, what is the value of P? It will be 180 degree divided by 10, that is equal to 18 degree. So we need to find X. So if what was X? X is equal to 7p, which was equal to Z. So when 7 is multiplied with 18 degrees, this comes out to be 126 degrees. So what is the value of X? It is 126 degree. So children, this is all for today, and for assignment you have to do exercise question number 1 from exercise 6.2. Thank you.